Hello everybody. Today we're going to talk about the distributive property. So before we talk about the distributive property and how to use it, first I need to give you a definition. So the definition we want to talk about is a term in mathematics. And a term is a number, a variable, or the product of one or more variables. So by definition, a term could be three different things. Now, I think everybody knows what a number is. That could be a positive or negative number. It could be a fraction, could be a decimal, any kind of number you could think of. And then a variable, I think we all know what a variable is as well. It could be x, y. Those are the most commonly used variables in algebra. Or it could be another variable. Sometimes the one that's a little tricky is the product of one or more variables. Well, if you remember from the beginning of the year, product means multiplication. So in algebra, when things are being multiplied together, they're touching. So here's an example of the product of one or more variables, negative 4xy. If you look, the negative 4 is touching the x and touching the y. That means they're all being multiplied together, okay? And you could add exponents to these variables, so it could be negative 4x squared, y to the third. That would still be the product of one or more variables, because if we break down x squared, that's x times x. And if we break down y to the third, that'd be y times y times y. So these last two were perfect examples of the product of one or more variables. And we'll talk about more about this the next lesson, but the negative 4, that's what's called a coefficient. A coefficient is a number multiplied to a variable or variables in a term. Okay, but again, a term is a number, a variable, or the product of one or more variables. So if you hear me use that term, or if you hear that term used in mathematics, you know what they're referring to. Now, we use the distributive property to take terms out of parentheses. Now, typically we don't, you can though, but typically we don't use the distributive property on a numerical expression. So right here we have a numerical expression. And I want to show you something. I want to show you that the distributive property holds true in mathematics and you can use it for anything. So let's say we use order of operations to simplify this expression. Well, 4 plus 5 is 9, right? And then 9 times 3 is 27. So if we simplify this expression, this numerical expression, using order of operations, we get 27. Well, actually, let's simplify it now using distributive property. Now, what the distributive property does, it allows you to take the term being multiplied to parentheses and multiply it to every term inside the parentheses. So what we're going to do is we're going to take this 3 and multiply it to a positive 4. And please keep in mind here that both numbers are positive right now. How do we know that? Because there's no sign to the left of them. Okay, so if you don't see a sign to the left of a number or a term, it's positive. So positive 3 times positive 4 is positive 12. I don't write the plus because it's the first term or the first answer. Then positive 3 times a positive 5 is positive 15. I do need to write that plus there because I need to separate the terms. All right, I don't want to link them together or anything like that. But now we could use order of operations and add them together, and 12 plus 15 is 27. So notice that we did the problem two different ways, but we still got the same answer. So the point in doing this is to prove to you that the distributive property works in mathematics or gives you equivalent expressions as if you would if you could simplify using order of operations. Now, typically we use the distributive property when we have algebraic expressions, because what it allows us to do is get the variable out of parentheses, because this is called a quantity. When something's inside parentheses, it's a quantity. And what we want to do, or the goal using the distributive property, is to get rid of the parentheses or eliminate the parentheses, get the terms out of parentheses. So what we do is we take the negative 6, that's touching the parentheses, we multiply it to the x. Then we take the negative 6 and multiply it to the positive 3. So negative 6 times x is negative 6x. I do have to write that sign if it's negative for the first term. If the first term is positive, we don't have to write that plus. And then a negative 6 times a positive 3, notice the plus, that plus goes with the 3. That's the sign for 3. A negative times a positive is negative, so it's negative 6x minus 18. Okay? And then we would look to combine like terms, and we'll talk about this next lesson, but these are not like, so this is our final answer. Okay? Simplified in its most algebraic form possible. Okay? Same thing here. Notice we can't add 2 and y because y could change. We don't know the value of y, right? So what we can do is take the x and multiply it to each one of these. Now what's nice for this problem is that they're both positive, right? Or all the terms, I should say. are positive. So x times 2 is a positive 2x. X times y is a positive xy. Those are not like terms, so this would be our final simplified answer using the distributive property. Now here we have three terms inside the quantity, okay? So again, we take the term on the outside, and notice that none of these are like, and we'll talk more about like terms next lesson with combining like terms, but none of these terms are like, meaning they don't have the exact same variable with the exact same exponent. So we take the -3 and multiply it to each term. Now, another thing I want to point out is that terms are separated by plus or minus signs. So, and the sign for a term is found to the left. So this 5 is positive. Now, we don't see the plus because it's the first term, right? And it's positive. But this 2x is negative, right? And the b is positive. The sign for a term is always found to the left. And I'll write that down because it's so important. So I'll definitely copy that down in your notes, pause the video. But a sign for a term is always found to the left of the term, or in other words, in front of it. Right? So we take -3 and multiply it to +5. That would be -15. Make sure if I'm going too fast at any point, you stop the video. -3 times a -2x, a negative times a negative is positive, so positive 6x. Okay? And then -3 times a positive b is -3b. All right? And then we always look to see if we combine like terms, but none of these are like, so that's our final answer. And we'll talk more about standard form in the next lesson. I'm not too worried about standard form for right now when you distribute. So that would be your final answer. Now, this gets a little tricky. Let's say we have two of the same variable being multiplied together. Well, we're going to use distributive property because we can't add these together. So a -3x times a positive x, and a -3x times a positive 7. Well, -3x times a positive 3x is -3x squared. You might be asking Mr. Pippage, well, how'd you get that? Well, a couple things. First, if you don't see a coefficient in front of a variable, it's 1. So if that helps you, write a 1 there. So -3 times +1 is -3. You should know, or it should make sense to you, that anything times itself is that thing squared. So x times x is x squared. But another way to help you get that answer is that if you don't see an exponent for a variable, its exponent is 1. And what you can do is, when you're multiplying variables that are the same, it's called having the same base, you could add the exponents. Because really, the exponents just tell you how many times you're multiplying that variable to itself. So 1 plus 1 is 2, so -3x squared. There's two different ways you should know to get -3x squared. And then -3x times a positive 7 is -21x. Now these are not like, we'll talk more about that next lesson, but they don't have the same exponents. The variable terms don't have the same exponents. All right? And now multiplying multiple variables together. 4a times -3 is -12a. Multiply the coefficient and the number. And then 4a times a positive 2b is, multiply the coefficients, 8ab. Just smudge those different variables together. We don't know what a and b are, so we just show the multiplication. Okay? Last two problems here. These are a little bit more advanced, but I definitely wanted to go over them with you. You could use the reasoning we used in the last problem for like this problem right here about adding the exponents. All right? That's probably the easiest way. So if we multiply the terms, well, 2 times 3 is 6, right? This is x times itself twice, x times itself twice. So basically we're multiplying x times itself a total of 4 times. So again, and it's not because 2 times 2 is 4. That's not true. It's because 2 plus 2 is 4. And the reason why I say plus is because the exponents are telling us how many times we're multiplying x times itself. Okay? So we're multiplying x a total of 4 times. If I just give you another example really quick, if I were to change this to a 5, well, this will become a 10. Okay? Because we're multiplying x times itself twice, x times itself 5 times. So in total, we're multiplying x to itself 10 times. So the shortcut is, if you're multiplying variables that are the same, add their exponents. Okay? And now a 2x squared times a 2y that's a positive 4x squared y. Since the variables are different, we just put them together. And finally, the last one, negative 2a times negative 2a, multiply the coefficients, positive 4a squared. Remember, these each have exponents of 1. You can add them, or you should know that a times a is a squared. And then a negative 2a times a positive 6b is negative 12ab. All right? So at this point, pause the video, try these examples on your own, and see how you did. The next 20 seconds will be blank. Okay, so hopefully you got a chance to try these on your own. So in the first problem, we're distributing a positive 7 to both these terms. Positive 7 times a negative 3, and I like to circle the terms, is negative 21. Positive 7 times a negative 4x is a negative 28x. That's all we can do with that, unless we put it in standard form, so that's our final answer. Now number 2 is a little bit tricky. So if it helps you, if you don't see a coefficient, write a 1 there. You could also write exponents if you want, if you don't see exponents for your variables. So a negative 1 times a negative 2 is positive 2, right? X times x is x squared. Okay? And then negative 1x times a positive 5. That's not too bad, right? Negative 5x. There you go. So hopefully you did really well with these. Hopefully you found this video lesson helpful. If you had any problems, don't be afraid to search online at some credible resources. All you'd have to search is the distributive property or the distributive property with algebraic terms, okay? There's plenty of resources out there on the distributive property, so if you're having any trouble, please check them out, okay? And if you're still having trouble after you check out resources, please let me know. Last thing to end, here's a perfect picture of a lot of examples of how to use math in everyday life. And we have sports, or how applicable math is in everyday life. We have a lot of parabolas here. That's an Algebra 2 concept. Time, you have a math equation here, right? So there's so many examples where math is applicable in your everyday lives. It's so important, even though we take a lot of things for granted because so many things are automated for us with our applications and computers and apps. Guys, think of it this way. People have to make those apps, right? And the people who are able to make those apps or come up with the ideas or design the programming for it, they're able to make a lot of money because they're doing things that people need or that people want. So